All right. It is Wednesday, day 3 of programming basics here. Today we are going to go over loops and operators. So this is the second part to programming. Yesterday we went over if statements, and who can tell me how to write an if statement?
Start with if, open
Okay.
parenthesis,
Okay.
and
And
then
what goes in the parentheses, if
con
anything?
conditions.
So the condition. Okay. And then,
Curly bracket to open a code block,
okay. So I'll indent here. All right. And then does anything go in here?
whatever you want the if statement to execute if the condition is met.
Okay. So we can say do something here. Whatever we want to do is going to go inside this area in the if statement. Okay. What about the else statement? When can we do that?
After the curly bracket on the bottom.
Okay. In what situation would we do an else statement?
We have more than one condition.
Okay. All right. What about an else if statement? When are we doing that? If we were to do it.
If we want multiple conditions met, or if we want one specific condition met.
More than one specific condition, right? So else if, and then more than one specific condition. Okay, that goes in here. And then if this specific condition doesn't get met, then what?
Then we need to run another condition.
Or the else.
Or the else. If we have another condition that we want to be met, and it's not met by the first if statement, and it's not met by the else if statement, however many we may use there, we're going to use the else here. And then that is going to take care of if statements. Cool. So you guys have a pretty good memory of this. Proud of you there. So let's go ahead and move on to for loops. This is the next big programming tool that you will use when running algorithms, creating functions. So we also know about variables, right? We know that there can be primitive data types. What are those again?
Something simple that usually denotes just one thing.
Okay. All right. Give me some examples, please.
Numbers, strings.
Okay, numbers and strings.
Boolean.
Yes, booleans. And what are booleans?
True and false.
True, false statements. Thank you. Okay,
Would
and
constant fall under that as well?
say that again, please.
Would constants fall under that as well?
Constants we haven't touched on that yet, but that's basically a name for a type of variable. So it's when we create variables, we use the keyword var right now. Okay, so let me just make a side note here. Variables. When we create a variable, we say var x equals, and then whatever we want here. We can also use other words to denote variables. We haven't touched on this yet, but I'm just going to give you a quick preview. So var is the first one. We can say let, okay, and const. We'll go over the meaning of these two when it's relevant. Okay, right now, all you need to do is use var. So good question, but no, it's not a primitive data type. Okay, what's a non-primitive data type?
Array.
Arrays.
Okay. Right, and why?
They contain multiple either numbers or strings.
Right. Okay. And so arrays, they look like this. And anything that we want in the array, we differentiate by a comma. Okay. Now, when we're reading an array and we're reading the index of an array, what number do we start with?
Array of 0.
0. So when we're reading an array, this is position 0, this is 1, this is 2, this is 3, and this is 4. Okay. And when we're reading the length, what position is index 0? What are we counting from when we're reading the length?
Left to right, it starts with 1 instead of 0.
Exactly. So this is a tricky little thing. Starts at 1, 2, 3, 4, 5. So the length equals 5. So if I say, well, let's not go there. We will get there. Okay, so that's all we need to refresh on. Let's move on to loops. Okay, so we have here a var index equals 2. Easy enough to remember what this means. And then in this next line below, we have index equals index plus 1. Okay. Index equals index plus 1. What does that mean?
You're adding 1
Index
to
by
the
1.
original.
Yes, we're making the value of index equal itself plus 1. So let's T-diagram this. We're going to say var and then the value. So we have index. Okay, that's from here. And then the first value is 2. As soon as we read this line, then we say index equals itself. Right now it's 2 plus 1, then it's going to be 3. Okay, what about this line below? What does this mean? Index plus plus.
Add 1 more to it.
Okay, how is that different than this line above?
It's not.
Does it
except for
continually?
one of them, you can-
Okay,
Go
so
ahead.
it's not any different. It's not any different at all. It's just a shorthand for the statement above. So these two are exactly the same. Technically, they may be a little bit different, but all you need to know is that those two right now do the same thing. They're the same. Okay, so index plus plus is the same as saying index equals index plus 1. Okay, let's get a status check before I move on. 1 through 10, how are you understanding this concept? Okay, don't just give a 10 to fit in. Like, we need an honest answer in case. I'm not accusing you guys here, just in case I need to explain a little bit better for somebody. Okay. So if we want to increase index, the first line it equals 2. The second line, we're going to say index equals itself, which is 2, plus 1, then it equals 3. No, plus plus just means plus 1. Plus plus means plus 1. Okay.
Yeah, every time, Keithan, for plus plus. Otherwise, you could do plus 1 plus 2 plus 3. You can change it, but plus plus is just plus 1.
Yes, plus plus is just going to be plus 1. Yep. Good thing to ask. Thank you, Keithan. And always ask, because there may be someone else that has the same question and they just don't have the thought to ask themselves. Okay, so it's good to always ask. Plus plus means plus 1. So on this line, we are at 3. My pen's not that small to write that. At this line, we're at 3, and then the following line, we're at 4. So if we were to console log index, at this point, we would get 4. Okay, now moving along. By that same token, we can decrement the value of num by running simply num minus minus or minus minus num. This is exactly the same as running num equals num minus 1 or num minus equals 1. There are times equals and divide equals operators as well that multiply and divide numbers, as you might expect. Okay. No need to work with division or multiplication yet. We are just going to work with minus minus. So if index plus plus means add 1, minus minus equals minus 1. Okay. All right. So reading this first line here, var counter equals 5. The next one's going to say counter equals counter minus 1. At this point, it's going to be 4. This is simple enough, right? We understand this. And now we're going to go on to counter minus minus. We know what this means. Okay, it means the same thing as the line above. And now here are multiplication and division. So you can do it this way as well. This is multiplication and division. So these are their own thing. There's also, as I read this way, okay, there is num minus equals 1. So this is the same as well, I should have wrote counter here. So maybe if I erase this. So I'm going to say, because we're keeping the same variable name, counter minus equals 1. That's the same as counter minus minus, and counter equals counter minus 1. Now we can change it to other values. We can change it to be 2 or 3 or 4. The minus minus is just going to be minus 1. Okay. This is just going to be minus 1. But you can give other values that you can increase by whatever value you need for the specific problem you're trying to solve.
Is there a specific preferred syntax in that situation if you're not using a a one up or down? Or is it just to eliminate rewriting the variable a second time in the line?
It's just there's a phrase called code golf. You're just trying to write the same thing without with as little strokes as possible.
Okay.
So you're just trying to minimize the amount of writing you're trying to do. So that's why they have a bunch of shorthand, and sometimes it makes the reading a little bit easier. It's easier for the eyes to flow instead of read words and then numbers. Yeah.
Real
Okay.
quick, what does syntax mean? I'm trying to get the lingo or the vocabulary down here.
Syntax is the style of writing. So for example, this is one style of writing it. This is another style of writing. This is, oh, actually, excuse me there. These two are not the same. This is one style of writing it. This is another style of writing the same thing. Just the style of grammar, style of writing.
All right, thanks.
Like, for example, you can say, howdy, or you can say, how are you doing? That's maybe a different syntax. Same meaning. Okay. All right.
Quick
Yes.
question. For the counter minus equal 1 is the same as counter minus minus, is what you're saying?
Yep.
Okay.
Exactly. And it's the same as counter minus equals 1, counter equals counter minus 1. There's 3 different ways to write the same thing. So at some point, someone probably had a standard way and then decided, oh, it'd be a shortcut if we write it this way. Oh, but we want a shortcut for writing specific values that we want to decrease by without writing the whole word. Okay, it's just maybe there's large variable names at some point, and you don't want to write the whole entire variable name. So you can use this syntax, counter minus equals 1. Okay. All right. So now we have a for loop. Okay. Take a look at this here. This is it. This is the for loop. We have, let's just read it. It says for var num equals 10, and then a semicolon, num is greater than 2, semicolon, num equals num minus 1, and that's all within a parentheses here. So that must be the parameters for this for loop. And then we have the function indicators of a beginning and ending function with these curly brackets. We have a console log in here, so that must be the area where we do something. And we're console logging 2 things, a string and also num. So num we know is going to be a variable because we've seen here var num. So let's go through this. Let's recreate this for loop. Okay. I'm going to copy this onto a notepad and then write it on Blackboard here. And then I'm going to explain how your eyes should read this for loop.
And then Josh, could you explain what the semicolons are for? Is that just for separation or for the loop, or what is it? How does the semicolons come into play?
Yes, exactly. We're going to get into that right now.
All right, perfect.
For loop. Okay, so I'm going to write the same for loop, but I'm just going to write it a little bit spaced out here so I have areas to make notes. So we have for, and then we said, oh, maybe I should start a little bit to the left here. All right, there we go. So we'll start from the left here, for, and then we say var num equals 10. And then we have a semicolon. And then we say num greater than 2, semicolon, num equals num minus 1. I ran out of space because I put too much space in the beginning. And then we have this here. Let me write this over. I really got to get this down. 4 var num equals 10. Num is greater than 2. Num equals num minus 1. And then we are going to console log. Num is currently and then a comma, num.
I have a quick question, kind of not to do with this, but for that string num is currently, I've seen in some of the examples in the learning platform as well as on the Algo app that an apostrophe instead of quotation marks is used to denote a string. Are those interchangeable, or should you always use quotation marks?
An apostrophe. So you can use single quotations or double quotes, but not an apostrophe. Apostrophe is for something else, and
Okay.
it's for we'll get across that bridge when we get there. So
Okay.
So let me see if I can change the color of my pen here so I can mark this up. So one moment here. If I can't, it's no big deal, but if I can, it'll be all the better. I think I did it. Yeah, we did it. Cool. All right. So when you're reading this for loop, there are different sections here. They're all divided by the semicolons. So let's go ahead and go through the first part. Your eyes should go to this first. This is number 1. So let's create a T diagram down here. Var value. Okay. So we have var num, and it's going to equal 10. Okay, so we've gotten this far. Now we have a semicolon here. So the next section that we read is going to be the section after this semicolon. Now we say num greater sign than 2. So what does this mean? This is saying while num is greater than 2, do something. So it's saying while num is greater than 2, do something. So we check our table. Is num greater than 2? So this is going to be the second thing we look at. Is num greater than 2? Yes, right? Right now it's 10. So we do something while it is true. So this is going to be part 3. So we do the thing, which is console log. And so I'll create a console section here. And we console log num is currently And what is num right now? 10, right? So num is currently 10. So once we do what's in here, then our eyes should go to here. This is the fourth part. I know it comes right after 2, but it's going to go in this order. 1, 2, then you do something, and then we increase num. We say num equals num minus 1. So now num is 10, so num equals num minus 1 is going to say that it's going to mean that num is now equal to 9. So now this is decreased, excuse me. And so then we go back to step 1. What is step 1? It declares the variable. It's declaring it to be 10, but we know from our t-chart here that this is just the starting point. Okay? It's actually 9. Num is equal to 9. And we look here and we say, well, num on part 2, while num is greater than 2, 9 is still greater than 2. So we're going to do something. So we go to step 3. We console log num is currently num. So we repeat this line here. Just pretend I'm repeating it on the console log. And that's going to say num is currently 9. This is going to be the new line. So it's going to repeat num is currently 10. Num is currently 9, all the way until we get to 2. So we go 8, 7. We repeat these lines 1, 2, 3, 4, 1, 2, 3, 4 until we decrease num all the way down to 2. Okay. 2 is not greater than 2. 2 is equal to 2. Okay. 2 is not greater than 2. So then we exit this for loop. We exit this for loop, and actually we still decrease num by 1 more. And then that becomes 1. Actually, no, that's incorrect. Know what I just said there. We just get to 2, and that's it. Got a little overboard there. So this is the order. We have this section here, the first part where we declare the variable. We look at what it's asking for. We're saying, while this variable is greater than 2, do something. So we go inside the function. We know that it starts and ends here by these curly brackets. We do the thing it asks us to do. Right now it's a console log, so we note on the console what we want to do. As soon as we finish the function, we go past the second semicolon, and we decrease num by 1. And every time we check this here, this middle part of the for loop, we're checking the value of num by our t-chart. We're keeping track of what num is on our t-chart here. So this is why it's important to t-diagram everything especially when we're working with for loops. We want to keep track of the value of num, because num is only going to be 10 the first time around. Okay, let's get a status check on how well we may be understanding this right now. Okay. All right. So what I'm going to do is I am going to, yes, good question, Perna. So you can make this equal num minus minus, and that would be the same thing as num equals num minus 1. Exactly. If it was num plus plus in the same statement, we would be increasing num constantly. We'd go from 10 to 11 to 12, and we essentially never exit this for loop because this condition would never be met. If we increase num instead of decrease num, num would never be equal to or less than 2. So in that case, you create an infinite loop. Yep. You just, your computer will fry maybe. And then you'll have to throw water on it. And then, no, I mean, there are some functions that you can run that your computer would get overwhelmed. This is not something to worry about. But that is a way to create an infinite loop. We don't want an infinite loop. We want the loop to serve a purpose. We want it to do something while something is true. While num is greater than 2, while this is still true, keep doing this thing, which is console log num is currently, and then declare the num value. So it would say num is currently 10, num is currently 9, num is currently 8, all the way until num is currently 3.
So if you're logging the current nums, do you still log the num next to it? So it'd be like 10 down to 10. You get what I'm asking?
Yeah, let's take a look at trace because I had limited space to show you guys. I just wanted to show you the order of how you should read the for loop and how the for loop reads when it's
Awesome.
running by the computer. I'll go ahead and run this through Chase. So if you guys want to take a screenshot of this, maybe, and I know my handwriting's not the best, but take a look at this and then take a screenshot, and then we'll move on to trace to give a better example of a for loop. Give you guys 5 more seconds here. 4, 3, 2. Okay, let's move on. Okay. All right, so let's go to trace. We're going to go there by going to the helpful links. Go there. I'm going to copy this here. I had some examples from yesterday's work here, so I'm going to erase that. I'm going to change the function name so it looks relevant. Run loop. And then I have to change it here on line 17 as well. Run loop. Okay, it's the same for loop I just went over. So let's see this in action. Okay, so here I'm going to pause and play to show each iteration of the for loop. Right now, num is undefined until it finishes this. So you see it's highlighted. Let me see if I can increase the view here. That's too much. Okay. So num is undefined currently. And if I press play, first num is 10. This is our T diagram here. So num is first 10, and it's checking here while num is greater than 2. Then it moves on to this area here. This is step 3. It's going to go on to this section, line 22. It's going to console log num is currently, and it's going to say with the value of num. So we see here in our terminal, the first print is num is currently 10. Okay, num then decreased to 9. Did you guys see that? After it ran the console, it ran this section here. Maybe I need to rewind that. Num is greater than 2, console. And after it did the console, it decreased num by 1. So now num is 9. Okay, and if we continue after step 4, it goes back to this middle section. It checks again. Okay, now while num is greater than 2, and we already console log 9, so I just rewound the steps here just to show you. So now we're at num equals 8. It already console log num is currently 9, so we're going to see what happens next. It console logs num is currently 8, so it ran num is currently 8, decreases, checks, logs, decreases, checks, logs, decreases, until it gets to a value where the middle section is no longer true. Okay, when we reach this point where num is equal to 2, num is no longer greater than 2 because 2 is equal to itself. It's not greater than itself. And then that's it. Our console will only log from 10 to 3. Did you guys get that? Good. I see some heads nodding. Okay, we're going to move on
Josh.
then. Yes.
Can you do a compound conditional in that section 2 of a for statement?
Okay. So if I go to code here now, and I say num is greater than or equal to 2, what should happen here?
You should get a 2 too.
I meant like what if you did like num is greater than 2 and a modular to make sure it only does it if the number's even.
Ah, okay. No, that you would do in an if statement within the for loop. So that is making it a little bit more complex. Keep the for loop simple like this. This is a compound enough for the for loop to say greater than or equal to. Okay, this is now checking 2 things. It's checking if num is greater than 2 or if num is equal to 2. If either of these statements are true, let's see what happens. It's reading it, then it's going to perform something now. Okay, so it's going to run. Right now, it's about to turn to 10. It just read it, and now it's 10. And we're just going to let this run and see how different it is with the equal sign. So num is 10. Logs, decreases, checks, logs, decreases, checks, logs. Going to do that all the way until logs decreases. Num is right now num is 3. Okay. And this is as far as we got last time. So we're going to decrease now. Now num is 2. This condition is still going to meet because while num is greater than or equal to 2. So num 2, right now it's 2, is equal to 2, so it's still going to do something. While this is still true, it's going to do something. So 2 is equal to 2, that is true, so it's going to do something. It console logs. And num is currently 2. So we got one step further with the equal sign, greater than or equal to. All right, now we decrease down to 1. And then we do a check again. Num is greater than 2 or equal to 2. It's not, it's less than 2. So we exit. We exit the for loop as soon as this middle condition, this middle section in the for loop is no longer true. As long as this condition is no longer met, we are no longer doing anything in this for loop. Okay, let's get another status check. I want to make sure you guys are following this. most complex programs, or most any program that just doesn't, it's not just like a display of a website that doesn't do anything. Most apps or functions or programs are a combination of if statements and for loops. These two combined make the computer work. Okay, so we've gone through this here, and let's see, what else are we covering today, this morning? Operators. I believe we went over operators yesterday. Let me just double check here. What are we doing on time? Where is our...
It was underneath loops. At the next one down.
Yeah, the next section.
This is an assignment, isn't it?
No, keep going down.
Oh, same page.
No, after the section loops 1, there's a section called operators.
Oh, that's right in front of me. Thank you. All right. So now let's go over operators. Thank you, guys. Here's a new concept, the modulo operator. Okay, let's go over some reading here. Modulo is like a magic Lego piece. Once you figure out how it's useful and when to use, it's a powerful tool. Here's a puzzle. How would you determine if a number is odd or even? Okay.
Make a loop to divide by 2. If it comes back as a decimal, it's not.
Yep. But we can't really get a decimal number here. So what this modulo operator does is checks for remainders. So let's do some math here. How many times does 3 divide into 9? Simple question. How many times? 3. Right? 9 divided by 3 equals 3. And after 3 divides into 9, how many remaining digits are there into that division?
0.
1.
0, right?
Oh.
3 divides into 9 evenly. So it divides into it 3 times, and the remainder is 0. Okay, what about 10 divided by 3?
Divides 3 times with a remainder of 1.
Yes. Equals 3 with a remainder equaling 1. So that is what the modulo operator is checking. How many times does it divide into the number with and what is the remainder that you receive at the end? By that remainder, you can check if it is a multiple of that number or not. If the remainder is 0, then 3 is a multiple of 9, or 9 is a multiple of 3. Okay, if the remainder, sorry?
On the remainder, is it always going to be a whole number, or will it be decimals as well?
No, we're just checking if there's any remainder at all. So we're just thinking whole numbers for now. Don't worry about the decimals. We're just thinking in whole numbers. So if we divide one whole number into another, and we have 0 as the remainder, then we know it is a multiple of that number. But if we have more than 0 as the remainder, if we have 1 or greater, then we know it is not a multiple of that number. So as Joe wrote in the chat here, 10 modulo, it's this percentage sign, 3 is equal to 1. Do you see why? Because it can divide into 10 so many times and have 1 as the remainder. So what if I say 8 modulo 2? What is that going to equal?
0.
0. So with this modulo 2, we can check if a number is even or not. Right? Because if we say 6 modulo 2, and it's 0, every time we do a modulo 2, we know that it's going to be an even number that gives us a 0 as a result. So, like, let's say we're writing an if statement. If let's say we have a variable, right? We have x, whatever x can be. If x modulo 2 is equal to 0, if this condition is true,
I do it with my students. It's very hard.
and we want to do something, if we want to check if x is an even number, then this if statement will pass. We can do something as long as this is true. So a modulo operator can be helpful when writing if statements to check for even numbers, for example. Okay, but let's say we want to do something more than even. Let's say we want to check if it's a multiple of 3. We can do that. We can do that with any number that we want. If we want to check if x modulo 3 is equal to 0, then we can do something in that case. So there's lots of instances that you can use this modulo operator. An if statement is one, where you enter into the parameters if a variable modulo a number comes out to be 0. Another way we can write an if statement, we can write it with the what does this mean? Exclamation mark equal sign.
Not equal to.
Yes, this means not equal to. Okay, so if we say if x modulo 2 is not equal to 0, what are we checking here?
If a number is odd.
Yeah, because if it's not even, it's odd. So this one on the right here, not including that 3, checks evens. This one checks odds. You see the difference? One is saying if x modulo 2, whatever number we put in there, modulo 2 is not equal to 0. If there is a remainder in that case, then we know that it's not even, therefore it's going to be odd. Okay, let's get a status check on this now. You know, if it's not making sense right away, give it some time to absorb. When I first learned about this modulo, like I got it, but it just didn't stick with me right away. Like I had to use the modulo multiple times. I had to write it in code, see it in code runner like Trace. I had to see it at work multiple times using it, and you will use it in practice for your assignment. Okay. So take a screenshot if you need how modulo works. On the right, we check evens. On the left, we check odds. Okay, give it a couple more seconds here. All right. So, let's see, other operators. I don't want you guys to be overwhelmed here, but there are some inbuilt functions in JavaScript here. Math.round. We know how to round a number, right? 5 and above is going to round. So if we have numbers here listed 1 through 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. If the number lands on 5 and above, we are going to round that number to the next available position. So we're just rounding. So what is 25 round to? Rounds to 30. Okay. What is 24 round to?
20.
20. Right? So what is 2.5 round to?
3.
3. Exactly. So this is what math.round does. Math.round is going to take the number that you enter into the parameter and round it to the nearest whole number.
Josh,
Yes.
I just thought, does JavaScript consider 0 as even or odd?
0 is just 0, I believe.
So if
Yeah.
so if you put like if is even or is odd, would it return true or false?
You're asking if 0 modulo 0, what would it be?
Yeah. No, I mean, never mind. I'll just check.
Okay. All right. Thank you. Let's continue here. All right. I need to exit this. Okay, so we know how math.round works. All right, now we're gonna say math.floor. Okay, so math.floor is gonna take a decimal number and bring it to the integer, the whole number integer, as it doesn't matter if it's 1, 2, 3, 4, 5, 6, 7, 8, 9. If it's 2.9, it will go down to 2. Okay, 2.4 will go down to 2. But if it's a negative number, then it seems like it's reversed, right? But it's actually still going down, because negative 2.9 is going to go down to -3. So we're just bringing that decimal point to the floor. So we're bringing it down. So if we write numbers this way, 0, 1, 2. Oh, what am I doing? Okay. 2, 1, 0. -1, 2. All right, so -1.3. If we use math.floor, we're going to bring it down to -2. If it's -1.9, we're going to bring it down to -2. That's what math.floor does. Okay, if a number is if a number is 2.5, math.floor is going to bring it down to 2. And so on. Okay, so what do you think math.ceil does?
The
Always
opposite.
round up.
The opposite, right? What's the opposite of the floor? The ceiling. So just think of this in reverse. So what is, for math.ceil, what is 2.5 going to be?
3.
Right, because it's going to go up. 2.4 is going to go up to the ceiling. 3. -2.9.
Goes to -2.
-2 because it's going up. Right? Think negatives are going down, positives are going up, 0 is right in the middle. So we want to go up for math.ceil. So -1.3. Where would that go?
1.
-1. Because -1.3 is below -1. Okay, cool. Let's get a status check on math.round, math.floor, and math.ceil, please. Thank you guys for participating. Okay, last one here. Math.trunc. It's going to truncate the number. What does that mean? If it has a decimal point, it's just going to remove that decimal point number. So in this case, we have 2.5. If we just slash this decimal point area away, it just becomes 2. Doesn't matter what's there. -2.9. Take away the decimal area. It's just going to be -2. This one's pretty simple, right? Just remove the decimal point area. Slash that off. Like you're cutting off a tree trunk. All right. So that's it for today. That's all the concepts we need to learn to complete today's assignments. So let's do a little quiz here. For loops. We have this for loop here. What, excuse me, what is it going to be the first part here that we read on the for loop?
Num equal to 0.
Right, we read the variable. And then the second part
Is less than equal to 5.
is num less than or equal to 5. That is part 2. What happens after we evaluate if num is less than or equal to 5?
You're going to run the console.log.
Yes, once we figure out if our condition is met, then we do what's inside the function. Whatever it is it asks us to do, we're going to do inside the function. Okay? Then what do we do after we finish doing what the function requires?
num plus plus.
Right. Num plus plus. So we increase num. And then what do we do? After we increase num, what do our eyes turn to? What is the code gonna run?
Check num less than 5 again for the updated
Yes.
value of num.
Exactly. We check num to see if it still meets that condition after we've changed it. After we've ran the function and changed num, we're going to check it again. And then what do we do?
Console log if this
Yep.
condition is met, and then run the loop again.
Yes, we do whatever the function requires if the condition is met, and then we change the variable num. Okay? And when do we do that until?
The condition num less than 5 is no longer satisfied.
Until this is no longer true. Exactly. Until that is no longer true, we are not going to do what the function requires. The function requires whatever's inside the curly brackets here. So this is no longer going to run until this is no longer going to run when this is no longer true. Num is less than or equal to 5. Okay, very good. Now let's talk about the modulo. What does the modulo do?
Gives you the remainder of any division function.
Yes, it checks if there's any remainder after a division, right? After we divide, we're going to check if there's a remainder. We can ask if the remainder is 0, 1, 2. So how can we check for even numbers using the modulo symbol? Okay. Write it out for me, Keithan, if you would. Divide by 2, but how is it exactly written? We want to say something modulo 2. Someone else knows, they can write it as well in the chat. Okay. All right. Now modulo 2, but there we go. Okay. Leo wrote the whole thing in an if statement. If x modulo 2 is equal to 0, this will check for an even number. Okay, let's write in the chat how to use a modulo symbol to check if something is odd. Exactly, Carlos. If x modulo 2 is not equal to 0, then we know that number x, whatever it would be, is an odd number if this is true, or if not equal to 0, if that is true. Yeah. So you have to ask yourself when you're using the modulo, in this case, the one Mike just posted, if x modulo 2 not equal to 0, is that true? Then the number is odd. Okay, lastly, let's do a quiz on what does math.ceil do? Round to the highest integer. Right. What about math.round? It rounds numbers, right? Okay, so remember, rounding numbers, it's going to round the number upward if it's 5 and above. It's going to round the number downward if it's less than 5. Round the decimal number to an integer, right? Based on what the decimal is, right? 2.4 is going to go down to 2. 2.9 is going to go to 3. So 2.5 and above is going to go up to 3. What about math.ceil? Math.floor. Did I already ask that one? No, I did math.co. Round down, okay. And math.trunk. There we go. Nice job, guys. Now, let's go ahead and go on a break now for 10 minutes. I think I'll set a timer here. 1 second here. Come on, where's my timer? Got it. Okay. All right, let's be back in 10.